Hello everybody, getting ready to do part 2 of lesson 1.6 today of Algebra 2 Math. And we have a 24-point class worksheet today. And we have 4 points here of note-taking. This is 1.6, perform operations with complex numbers. And we're going to start out here with sums and differences of complex numbers. To add or subtract two complex numbers, add or subtract the real parts and their imaginary parts separately. So a sum of complex numbers would be this situation here. Then we add a plus c, and then b plus d times I would be how you would add complex numbers. And then the difference of complex numbers would be a minus c plus b minus d I. So we factor out the I and then we add our coefficients for our imaginary number. Write the expression as a complex number in standard form. We have this example here. So we have 8 minus I. So we add our real numbers here first, and then we add our coefficients now of our imaginaries, and we have -1 plus 4 times I, and we end up with this 13 plus 3I. This will be a complex number written in standard. So add or subtract complex numbers. So we're going to add, or rather we're going to subtract these two complex numbers here. So we're going to again add, we're going to subtract 7 minus 3 plus -6 plus 6 here. -6 is this to make this a positive 6 times I. And that will come out to 4 plus 0I, or just 4 for this combination here of two complex numbers. And then add or subtract complex numbers. C, 10 minus 6 plus 7I plus 4I. So we put this in brackets now. We have 10 minus 6 minus 7I. So we're going to combine these two real numbers here. Then we have the 4I here. And then this will be 4 minus 7I plus 4. Then to continue, we have 4 plus -7 plus 4 times I, and then that would be 4 minus 3I. That would be how you would handle that situation. Write the expression as a complex number in standard form. Students, this is yours here. Pay attention. So your students. So we have this situation here, 9 minus I plus -6 plus 7I. So we're going to group our two real numbers here, 9 plus a -6 plus a -1 here plus 7 times I. And then we group these together so that we can add those coefficients. And then we have 3 plus 6I would be the combination of these two complex. We have electricity problem here. Resistors, inductors, capacitors, all oppose the flow of a current. This is called resistance for resistors and reactance for inductors and capacitors. The circuit's total opposition to current flow is called impedance. We have a lot of jargon here. All these quantities are measured in ohms. So we have this situation here. The table shows a relationship between a component's resistance or reactance. So we have resistor, then Li here. We have a complex number here. And then a -Ci here. We have another complex number here. And so this is a table here. This is in your classwork, students, page 7. So use this as a reference. A series circuit is also shown with a resistance or reactance of each component labeled. So what are we going to do with that? Here's another way of looking at this relationship here. So we have a inductor here. This is an inductor. And then this would be a resistor here. Oh, this would be a capacitor. -Ci will be a capacitor here. and then this would be a resistor up here. So we have three different electrical operations happening there. So what are we going to do with that? Well, the impedance for a series circuit is the sum of the impedances for the individual components. Find the impedance of the circuit shown. So here are numbers for different levels of electrical resistance. The resistor has a resistance of 5 ohms, so that would be here. So its impedance is 5 ohms. The inductor has a reactance of 3 ohms, so its impedance is 3i ohms. The capacitor has reactance of 4 ohms, so its impedance is negative 4i ohms. Impedance of the circuits would be this now. When we add all these together, we get 5 plus 3i plus a negative 4i. Add the individual impedances and then simplify, which equals 5 minus I here. And combine these two, you get 5 minus I. So the impedance of the circuit would be 5 minus I ohms. So this gives you a little background here of where you can use complex numbers in electric engineering. Okay, in example 3, what is the impedance of the circuit if the given capacitor is replaced with one having a reactance of 7 ohms? And then down here, since this is yours now, find the impedance of this circuit here. Use your classwork sheets as references to do your independent. We're going to do our guided practice now. In example 3, what is the impedance of the circuit if the given capacitor is replaced with one having a reactance of 7 ohms? So this would be the expression here. The impedance of the circuit will be 5 minus 4i ohms if we replace this with 7 ohms instead of the 4 ohms. So that just gives you some background on what you can do with complex numbers. That is part 2 of lesson 1.6, Algebra 2. And contact me for worksheets and other materials for the course. Thank you.